Today we are going to learn about mastering Python code profiling with cProfile. We will dive into the essentials of using cProfile to optimize Python applications, focusing on identifying bottlenecks and enhancing code efficiency. Welcome to our session on mastering Python code profiling with cProfile. Code profiling is a process used to analyze the execution of a program to determine where optimizations can be made. It's essential in Python development to ensure your applications run efficiently and perform optimally. We'll explore various profiling tools, but our focus will be on cProfile, a built-in Python tool that helps developers identify performance bottlenecks and optimize code execution. Understanding and applying code profiling techniques is crucial for enhancing application performance and achieving faster, more responsive software. Before we dive into the functionalities of cProfile, let's start with setting it up in your Python environment. cProfile comes pre-installed with Python, so there's no need for an additional installation. However, it's crucial to ensure your Python environment is properly configured. Start by checking your Python version using the command Python version to confirm compatibility, as cProfile works seamlessly across most modern Python versions. Familiarize yourself with basic cProfile commands such as python cProfile your _script.py, which runs your script under cProfile's profiler. Ensure that your environment variables and paths are correctly set to avoid issues during profiling. Proper setup is the first step towards effective profiling and optimization. Now that your cProfile is set up, let's explore its basic usage. Running cProfile involves using the command line interface. Execute your Python script with cProfile by typing python cProfile script.py. This command will output profiling data to the terminal, detailing the time spent on various functions. You can customize the output using options like S to sort the results by criteria such as time or calls. For instance, python cProfile sTime_script.py sorts the output by the time spent in each function. Additionally, you can save the profiling data using the option, allowing you to analyze it later with tools like Stats or SnakeViz. Mastering these commands is essential for efficient profiling.
Once you've run your script with cProfile, you'll be presented with a wealth of information regarding your program's performance. The output includes metrics like calls, number of times a function is called, time spent in the function, and cumulative time, total time spent in the function, including calls to subfunctions. Analyzing these metrics helps identify functions that are bottlenecks in your code. Use the calls metric to see frequently called functions and cumulative time to pinpoint functions where most of the execution time is spent. For a more in-depth analysis, load the saved profile data into the stats module, which allows you to print, sort, and filter profiling data, offering deeper insights into your program's performance.
Identifying performance bottlenecks is a crucial aspect of code profiling. Bottlenecks are sections of code that significantly slow down your application's performance. Start by examining the functions with the highest cumulative time and calls. Focus on optimizing these critical functions by considering algorithmic efficiency and potential refactoring. For instance, replacing inefficient loops with list comprehensions or leveraging built-in libraries can yield substantial performance gains. It's also beneficial to explore alternative algorithms that perform better for your specific use case. Implement changes iteratively, continuously profiling and testing the application after each optimization to ensure improvements are achieved without introducing new issues. This methodical approach is key to efficient optimization.
To enhance the profiling process, integrate cProfile with other profiling tools. Begin by using the stats module for a more detailed analysis, allowing you to filter and sort profile data using various criteria. For visual representation, consider using SnakeViz, a browser-based visualization tool that turns cProfile data into interactive graphs, making it easier to identify performance hotspots. Additionally, combine cProfile with memory profilers like memory_profiler or Guppy to gain insights into memory usage alongside performance metrics. Profiling your application in different environments, such as development and production, can reveal environment-specific performance issues. Employ advanced profiling techniques, such as sampling profilers, for scenarios where cProfile's deterministic approach may introduce overhead. Profiling complex applications requires a strategic approach. Adopt a modular profiling approach by breaking down the application into smaller components and profiling each module individually. This helps isolate performance issues and reduces the complexity of analysis. Profile in stages, starting with high-level functions and gradually moving to detailed analysis of lower-level functions. Focus on hotspots identified in previous profiling stages to prioritize optimization efforts where they are most impactful. Minimize profiling overhead by avoiding excessive logging or data collection during profiling sessions. Establish a regular profiling routine, integrating profiling into the development process to catch performance issues early. Following these best practices ensures efficient profiling and optimization of complex applications. Let's apply what we've learned in a real-world scenario. We'll profile a Python script designed to process and analyze large datasets. Initial profiling using cProfile reveals that a data parsing function consumes most of the execution time, identified as a bottleneck. By refactoring the function to use efficient parsing techniques and leveraging built-in libraries, we achieve significant performance improvements. Further profiling shows reduced execution time, allowing us to focus on optimizing other parts of the script. This iterative profiling approach, combined with targeted optimization, demonstrates how applying cProfile effectively can lead to substantial gains in performance, transforming a sluggish application into a fast and responsive one. In conclusion, mastering Python code profiling with cProfile is a vital skill for optimizing your applications. We've covered various techniques to set up, use, and interpret cProfile, identify and address bottlenecks, and integrate with other tools for a comprehensive profiling strategy. Remember, profiling is an ongoing process. Regular profiling and optimization ensure your applications remain efficient as they evolve. Keep learning and exploring advanced profiling techniques to stay ahead in performance optimization. Thank you for joining this session on Mastering cProfile. Keep practicing and applying these skills to enhance your development process and deliver high-performing Python applications.